in the last video we completed the finding period block group of an element. Now in this video we'll start with the Z effective and shielding effect. So Z effective. The definition for Z effective is effective nuclear charge. In a one line, if you want to understand the definition of Z effective, effective nuclear charge on outermost electron is the Z effective. Definition: the net attraction force of nucleus on outermost electrons. This is called the Z effective or effective nuclear charge. In this, we will take an example to understand it better. Sodium will take as an example. One sodium atom will have nucleus and electrons cloud. So in the nucleus, protons and neutrons will be there, and electrons will be in electrons cloud. How many electrons are there in, what is the atomic number of sodium? 11. So 11 electrons and 11 protons and 11 neutrons also, but we will not consider because neutrons don't have any charges. And electron has minus charge, proton has plus charge. And from the Coulomb's law, we'll draw the structure for sodium. This is a nucleus and plus charge because nucleus will have protons in it, and these are orbits. So total 11 electrons are there in a sodium atom. What is the electronic configuration of sodium? 2, 8 and 1. Total 11 electrons, so 2, 8, 1. 2 electrons in a first orbit, then 8 electrons in a second orbit, and then 1 electron in third orbit. So this nucleus, which is having the plus charge, will attract the outermost electron. As well as electron will also attract the nucleus. According to Coulomb's law, force of attraction will be K Q1 Q2 upon R square. Q1 is the charge of electron in outermost shell. Q2 is the charge of protons which are on nucleus, and R is the radius, distance of outermost electron to the center of nucleus. This is R, and this whole is force of attraction. Experimentally, it has been found that the force between nucleus and the outermost electron is less than the calculated. What we will calculate with this formula, that force is more than the actual force of attraction, or you can say the actual force of attraction is less than the calculated force of attraction. Experimentally, it has been found that force between nucleus and outermost electron is less than calculated. And now we will see why the force of attraction is less than the calculated force. In a one word you can say Z effective, but in this one word you can't understand everything, so I will explain it here very clearly. Because 11 electrons are there, electron clouds is there, two inner orbits are there, and 10 electrons are accommodated inside the inner orbit. 1 and 2, 2 electrons in first orbit, 8 electrons in second orbit, and 1 is in third orbit. And this is happening because the electrons which are in inner orbit will repel this electron. So the net force of attraction, these electrons will repel. Okay, so in this direction outside the atom, and nucleus is attracting. So the net force of attraction will be the less than calculated force of attraction. And this net force is called the Z effective. Net force is equal to attractive force minus repulsive force. Now the comparison of Z effective, where the Z effective will be more, where the Z effective will be less, we'll see those factors here. And I will rub this atom diagram. Now the comparison of Z effective. Comparison of Z effective. First one, the principal quantum number Z effective is inversely proportional to the principal quantum number. And Z effective is inversely proportional to 1 upon n. N is the principal quantum number. Then the second comparison, subshells. S subshell will have more Z effective than P, then D, then F. As we know that S subshell is more near to the nucleus than P, then D, and then F. So the Z effective for S will be more than P, then D, then F. We'll solve an example to understand it better. Compare Z effective order among these. This is the question. Compare Z effective order between 4S, 3D, 4P, 5F, 1S, 2P, 6F, and 5D. So because these numbers are the principal quantum number 4, 3, 4, 5, and these S, D, P are subshells. So which principal quantum number is highest here? 4 4 is higher than 3, then 4 is higher less than 5, so 5 is higher, then 1 is less than 5, 2 is less than 5, then 6 is the highest number, principal quantum number. So this will be the highest. So 1s is more, then 2 principal quantum number is only 1, 2p, then 3 only 1 is there, 3d, then 4s is here, 4p is there, so 4s will be more because s is more near to the nucleus, then 4p, then 5f, and then 6f. So this will be the comparing Z effective order. Now the Z effective in period we will see. Z effective in period. In period, Z effective is equal to Z minus S. Here S is the shielding electrons. And Z, so Z is the total electron present in the atom, one atom. So Z effective in period will increase from left to right, and this we can calculate from this formula also. If we take second period, for example, second period's elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, then fluorine. So total how many electrons are there in lithium? 3 electrons are there, and 2 electrons is inside. From the electronic configurations, 1s2, 2s1. Also from this electronic configuration you can see 2 electrons are in one principal quantum number or one first orbit, then 1 electron is in second orbit. So 3 minus 2 is equal to 1. For beryllium 4, and then here 1 electron will come, and then this is also 2. 4 minus 2 is equal to 2. Like this it will come 1, 2, 3, 4, 5, 6, and 7. So you can see the Z effective number is increasing from left to right. So lithium is having the least Z effective, then beryllium, then boron, then carbon, then nitrogen, oxygen, and then fluorine. Fluorine is having the highest. For a group, Z effective in a group, we'll see in a group, we'll take example first group: lithium, sodium, potassium, rubidium, and cesium. So this, for lithium, this will come same as here, 3 minus 2 is equal to 1. For sodium, 11 total electrons are there, and 10, 10 electrons are inside the first orbit. Like 10 electrons are inside after the first orbit, outermost orbit. Then this is 1, then here this will also come 1, here also 1, and 1. So Z effective in a group, it is coming the same. So it actually decreases Z effective because the radius down to the group is increasing, but the Z effective is coming mathematically same. So actually the Z effective is decreasing. In some books, approximately equal also they are saying. So approximately equal. So we have seen Z effective in group, in period. Now we will see the shielding effect. What is shielding effect? Shielding effect. We know that the electrons which are not in the outermost shell are repelling the electrons which are in outermost shell. So this effect of repelling, or these electrons are creating shield between nucleus and these electrons which is inside the outermost and first orbit, are creating the shield between outermost electron and nucleus. This effect is called the shielding effect. Inner electrons acts as a shield between nucleus and outermost electron. So inner electrons are called the shielding electrons, and this effect is called the shielding effect. So inner electrons are called shielding electrons, and this effect is called shielding effect. So from this whole discussion, in a very short we can understand that Z effective in period is from left to right is increasing. In a group from top to bottom, it is mathematically it will come the same, but it is decreasing. And in the subshell, S subshell, Z effective will be the highest, and in F it will be least. And Z effective for principal quantum number is inversely proportional. And what is Z effective? That also, that the net force calculated between nucleus and outermost electron is called the Z effective. In our next video, start the atomic radius, and in that we'll do the questions and we'll do it very clearly because this topic is very important for JEE and NEET. So atomic radius, we have many subheadings also, like ionic radius, van der Waals radius, metallic radius. So these all the headings will do with the examples also. Thank you.